Okay, it looks like our connection's not working for the tablet, so we'll just work these on the board. Question number 1 on page 224 for the chapter 4 practice test. Write the following in Egyptian numerals. So what you need in your notes are what those Egyptian numerals mean. And let's do 1B. We'll just do one of each of these, so your homework will be doing the rest of them. But 735, 700, that means we go 7 scrolls. And then 30, what do we do for 30? See, you have to have in your notes somewhere, a scroll is 100, a heel bone is 10, and then 5 ones. Okay? So question 2B, write the following in decimal. It has a scroll, a heel bone, and what? 2 heel bones. So that would be 100, 20, and 1. So that'd be 121. So somewhere in your notes, you need to take to the test on Friday what a scroll's worth, what a heel bone's worth, and what a mark's worth. Question number 3 says write 735 in Babylonian. So we go 735. Now we're going to write it in Babylonian. So do you have your Babylonian symbols there? Your notes for Babylonian? What do we have? A little, this is 1, and what else? This little flying thing. On the test, it'll just be a little thing like that. That's 10. And then when you put one of these over here, followed by a space, that's 60. So, how many 60s in 735? Divide 735 by 60. Two 60s is 120. So there's 15 left. So I want 12 60s. Everybody follow that? I want 12 60s. So I go 10, 11, 12, and then leave a space. Maybe I'll put it over here. I go 10, 11, 12, then I leave a space because these are 60s, so I have 12 60s. So that takes care of what, 720? So now I need 15 more, so I come over here and put a 10 and five ones. Okay? Problem number 4 shows, let's just do 4B. Shows 2 of these little things, followed by a space, and then one of these and one of these. So this means 2 times 60, because of that space, that's 120. And this is 10, and this is 1, so that's 11. So that would be 131. Okay? Number 5. 23 times 21. 23 times 21. And what do they want us to do? By successive duplications. So I have 1 times 21, 2 times 21, 4 times 21, 8 times 21, and 16 times 21. And of course, since I'm doubling these, I just double that. That's 8. 328. Okay? So now I'm looking for 23, so I have a 16. 16 and 8 would be 24. That's too much. So I have a 16 and a 4, that makes 20, 22, 23. So the answer is going to be adding all of these right here together. And I think on the test, it won't ask you to add them together. What the test will do is it will show this, and then it'll say which rows do you add together, and it'll give letters to the rows. Yes.
Shouldn't it be 84 for 4 times 21?
Yeah, should be 84. There you go. Thank you. And that would be what, 168 and 320, no, 336. Thank you. And then on the test it'll say which rows do you add together to get the answer. And then the second thing it'll ask you to do is do the problem. Is it the same thing? Yeah. Number 5, 23 times 21 with, what's the second one called? Mediation and duplicity. So I divide this by 2 and I get, what, 11? And I double this and I get 42. I divide this by 2, I get 5. I double this, I get 84. I divide this by 2, I get 2. I double this, I get 168. I divide this by 2, I get 1. I double this, I get 336. And then, which ones do I use? The odd ones. Remember that? So I take this one, and this one, and this one, and this one, and add those together to get the correct answer. Okay? So what are we doing now? Number 6. Write these Roman numerals in decimal notation. LX, no, let's do B. XLVII. But it's got a line over it. So first, let's do, what's XL? Do you have your Roman numerals there somewhere? If you don't have them in your notes, you can't work them on the test. So put your Roman numerals, what the letters are worth. L is 50. Since X is 10, it's in front of it. That makes this 40. 5, 6, 7. So I have 47, but the line over it says 47,000. Okay? If this would have been written XL with a line over it, and then VII, that would have been 40,007. Everybody see that? So look to see, whatever the line covers, that you take times 1,000. Number 7. I guess let's do 22,000. 22 would be 10, 20, 1, 2, and then 1,000 would be put a line over the top of it. Number 8. Expanded form 2507. This is 10 to the 0, 10 to the 1, 10 squared, and 10 to the third. So you go 2 times 10 to the third plus 5 times 10 to the second plus 0 times 10 to the first plus 7 times 10 to the 0. And on the test, when they have the choices for answers, since this is 0 times this number, they'll leave that out. So on the test, it'll just look like this. 2 times 10 to the third plus 5 times 10 to the second plus 7 times 10 to the 0. But I put that 0 in there so I don't lose track of any of the spaces. But you see, the clue here is on top of these digits, put their place values with 10 as the exponent. Number 9. Write the following in decimal notation. So I have, now watch what I'm going to do. I'm just going to leave my place values up here. I have 10 to the third, 10 to the second, 10 to the first, 10 to the 0. And does that take care of all of them for number 9? A? Yep. No, let's go ahead. Let's do B. So I'm going to have 10 to the 4th. Now, what goes under 10 to the 4th for 9B?
5.
5. What goes under 10 to the 3rd?
9.
What goes under 10 to the 2nd?
0.
Good. What goes under 10 to the 1st?
0.
What?
4.
Oh, we're getting confused here, huh? Number 9. We have 10 to the 4th, 10 to the 3rd. Oh, no, there's no. What is that? That's 10. Okay, 10 is the same as 10 to the 1st. So that's 4. And then what about 10 to the 0?
0.
There isn't one, so you put a 0 there. So what's the number? 59,040. You understand the key to this expanded stuff is your place values. Just bring a sheet of paper with your place values on it and say that's how I'm going to work those. Number 10. Oh, skip number 10. It's not on the test. And you don't have to do it for homework either. Number 11. Perform the indicated operations. 3 to the 4th times 3 to the 8th. Equals 3 to the what?
12.
Now, you say, why is that? Because when you multiply exponential numbers, you add the exponents. If you don't have those rules in your head, you put them on paper and bring them with you to the test. And then 11b, 2 to the 9th, divided by 2 to the 3rd, equals 2 to the what?
6.
What?
6.
6. Because when you're dividing, you subtract the exponents. This one from that one. The bottom one from the top one. And I guess we should do one more. What if it said 2 to the 9th to the 3rd power? What would that be? 2 to the 27th. Because the power to a power you multiply.
Yeah.
That's what you meant, wasn't it? Yeah, I knew that. That's why I put it up there. That's what you meant. Okay? So if you don't have the rules for working with exponents in your head, put them in your notes and bring them to class with you. Number 12. Skip that one. It's not on the test. Number 13. Change the following to decimal notation. 203 in the base 4. (203) in the base 4. When I see base 4, I say this is for the 0, this is for the 1, this is 4 squared. Okay? So I have 2 of these. I have 2 4 squareds. What's 4 squared? 16. 4 times 4. So that's 32 plus 0 plus 3. So what's the answer? 35. Okay? Is that right? You checking me out, see if I'm doing my computations right? Yep, 35. 143 in the base 5. That's 5 to the 0, 5 to the 1, and 5 squared. What's 5 squared? 25. So I have 25 plus, what's 4 times 5? 20 plus 3. And that adds up to 48. And then there's one more there. 1101 in the base 2. That's 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd. What's 2 to the 3rd? 8. What's 2 squared? 4. So I have 1 8 plus 1 4 plus 0 plus 1, which is 13. Everybody see what's going on? Number 14. One, 5, 2 in the base 8. In the base 8. So that's 8 to the 0, 8 to the 1, and 8 squared. What's 8 squared? 64. So I have 64, one of those, plus 5 eighths, 40, plus 2. Well, what is that? 100 and what? 6? Everybody see what's going on? My pen's wearing out, so I'll get another one. So what's the next one? A2C in the base 16. So this is 16 to the 0, 16 to the 1, and 16 squared. What's 16 squared? 256. Is that right? 15 times 15? I got it right? So now what's A? You remember in base 16, it goes 10, 11, 12, 13, 14, 15. 8, 7, 8, and 9 are just like in our system, but here, then it goes A, B, C, D, E, F. So what's A? A is 10. So 10 times 256 is 2,560. 2 times 16 is 32, and C is 12. So add 12 to that, and what do you come up with? 2,604. Did I get that one right? 14B. Yeah, good. 15. Convert 33 to base 5. To base 5. So that means if I want base 5, I have 5 to the 0, 5 to the 1, 5 squared. And then 5 to the third. Well, 5 squared is 25. So that means, and 5 to the third would be 5 times 25, which is, what is that? 125. So I don't have any of those in 33, but I do have a 25, so I subtract 25, and that leaves me with 8. So I have one of these. And then 8 would give me one of these, minus 5, and then 3 of these. See how I'm just using my place values? Now, the textbook, and we did this when we did that section, the textbook showed repeated division to find the answer, and you can use that method if you want, but this probably, since we're looking at place values to do this stuff, if you want to just keep thinking through with place values, this is probably just as fast as doing that long division method of finding the answer. Then the next one is to base 6. So I go 6 to the 0, 6 to the 1, 6 squared. And look at this. So this is 6 squared is 36s. Well, I only have 33. So I don't have any of these. But how many of these would I have? 5, because 5 times 6 is 30. That leaves me with 3 ones, so it's 5, 3 in the base 6. Everybody follow that? Just put your place values up there, and whatever the base is, and think about your place values, and you'll be okay. Number 16. Convert 39 to binary. So now they want me to take 39, and binary is 2 to the 0, 2 to the 1, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. Let's move 39 over here. So what we got so far? This is 4s, this is 8s, this is 16s, this is 32s. 2 to the 6 would be 64s. I don't have any of those, but I do have a 32, so I put one of these and subtract 32. 7, so that means I have no 16s and no 8s, but 7 would be a 4, a 2, and a 1. Everybody follow that? You see that process? Good. Convert 47, number 17, to base 8. So now they're saying use 47. And base 8 is 8 to the 0, 8 to the 1, 8 squared. Well, 8 squared is 64, so I know I don't have any of those. But how many 8s do I have? Maybe it helps to put little boxes down here to fill them in. How many 8s do I have in 47? 5 of them. So I go minus 40. That leaves me with 7. So 5, 7 in the base 8. There's your answer. 5, 7 in the base 8. Everybody follow that? So let's do it in base 16. And base 16 would be 16 to the 0, 16 to the 1, 16 squared. What's 16 squared? I need to get my calculator out here for some of this stuff. You going to tell me? 256. 16 squared is 256. I don't have any of those in 47, do I? Is that what we're doing? 47. I don't have any of those in 47. But I do have some 16s, so there's none of these. But I do have some 16s and some 1s. How many 16s in 47? Well, 3 times 16 would be 48. That's too much, so I put 2 times 16, and that gives me 32. And that leaves me with 15. So I need 15 over here. So how do I write 2 and 15 in base 16? 2 and what? F. Remember you have your chart there to show what the letters are? 2F in base 16. All right? Number 18. Perform the indicated computations in binary. 1101 plus what? 101. Draw the line and add. What's 1 plus 1?
2.
2.
Well, 2.
How do I say 2 in binary?
1 0.
1 0.
A 0 and carry a 1. What's 1 plus 0 plus 0?
1.
1. What's 1 plus 1?
1 0.
2. And how do I say 2?
1
0 and carry the 1. What's 1 plus 1?
2.
0 and carry the 1. You follow the process? You're actually starting to think in binary, aren't you? All right. Do we feel powerful? Then 18b is subtract. One 101 minus, what are we subtracting? 111. 111. What's 1 minus 1?
0.
0. This is base 2 we're looking at here. So what's 0 minus 1? See, I can't do that. I have to borrow from here, which means I took this away, but that gave me 2 of these because that's my base. What's 2 of these minus 1 of these? 1. I have 0 minus 1, can't do that, so I turn this to 0 and I have 2 of these, and 2 of these minus 1 would be 1, so there's your answer. You see, it's just like decimal, except you're not borrowing 10, you're borrowing 2 if the base is 2, you'd be borrowing 8 if the base is 8, you'd be borrowing 5 if the base is 5, and borrowing 16 if the base is 16. Number 19. 1101. No, let's do B. 10110. 10110. And what's it say next? 101. And I multiply. So I take 1 times all of this, I get 0, 1, 1, 0, 1. I take 0 times all of that, I get 0, 0, 0, 0. Everybody follow it so far? Then I take 1 times all of that, and I get 0, 1, 1, 0, 1. Then I draw a line and do what? What's the procedure with multiplication?
Add.
Add. Just add add these 3 numbers up. So I have 0, 1, 1, 1. What's 1 and 1? 2. How do I say 2? 1, 1. There you go. That looked too easy. I better check to see if that's the answer. 19b. 110, 1110. 101110. Good, we got that one right. Well, we're on a roll here, aren't we? Number 20. Oh man. I would love to do a division problem this morning, but I'm trying to get you ready for a test on Friday. So I'll just tell you, there is not a division problem on the test. That is so sad. So, since it's not on the test, I mean, doesn't that help? I mean, when you're thinking about, what do I have to know for this test? What do I need to practice for this test? So, if there's no sense practicing number 20 if it's not there, so skip number 20, and let's go to 21. 6, 3, 2 in the base 8 plus 4, 6. And now I know how to make people smile in math. Take binary division off of the test. You people. 6, 3, 2 in the base 8. And where did it go? Plus 4, 6 in the base 8. What's 6 plus 2 in your head? 8, right? How do we say 8 in base 8?
1, 0.
Thank you. Put down a 0 and carry the 1. Everybody understand why we said that? Watch. Let's start counting in base 8. 1, 2, 3, 4, 5, 6, 7. Whoops. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. You follow what's going on? So if you need to bring a chart of numerals in the various bases to help you see what's happening, bring it in your notes with you. So 6 plus 2 is 8. Oh, this is 8, but that's 1, 0. 9 is 1, 1. Now we're talking about base 10 here, see? Base 10. All of these are the same, but when you get to 8, 9, and 10, and 11, it changes because it's base 8. So now what's 4 and 3 and 1?
1, 0.
Yeah, you put down the 0 and carry the 1. And what's 6 and 1? So it's 7, 0, 0 in the base 8. Okay? Number 22. Multiply 3, 7, 8 times 5. That's not bad. Multiply 37 in the base 8. 37 in the base 8 times 5 in the base 8. So what's 5 times 7 in your mind? 35. Everybody agree? So how do I say 35 in base 8? 8 to the 0, 8 to the 1, 8 squared. 35 would be 4 8s, 32. 4, 3 in the base 8. Everybody agree with that? So what do? I put down a 3 and carry the 4. What's 5 times 3 in your head? 15 plus 4 would be what? 19. How do you say 19 in base 8? How do you say 19? 2 8s is 16. 2 3, is that right? So I put 2 3 here in the base 8. Is that the correct answer?
Yeah.
It is? Good. So, problem number 23. Subtract 46 in the base 8 from 632. Now we're just doing subtraction. You go, well, that's not a problem. Whoops, let's leave that up there. That's not a problem. I can't subtract 6 from 2, but I borrow one of these, that becomes a 2. And what did I borrow? I borrowed 8. So 8 plus 2 would be what? 10. Everybody see that? So what's 10 minus 6? 4. Then I have 2 minus 4. I can't do that, so I borrow here. What did I borrow? 8 plus 2 is 10 again. So 10 minus 4 is 6. 5, 6, 4 in the base 8. What's so hard about subtraction? Borrowing? But then you didn't like borrowing with decimal either, did you? So why would you like borrowing with 8 if you don't like borrowing with decimal? Figures. At least you're consistent. So if you don't have to do division with binary, what do you think? Number 24 is not on the test either. So you don't have to do division of anything on the test. So skip 24, and then let's look at 25. 2BC plus 5D. 2BC plus 5D. And this is in the base 16. So let's just come over here and put our base 16 digits up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How do I say 16? Base 16 is 16 to the 0, 16 to the 1. Oh, 16 would be 1, 0. 1, 16 and no ones. See that? What would 15 be? Put 16 down here. This is base 10. The way we think. Over here is base 16. So that's the same. Nope, no 10. What do we put in place of 10? A, B, 12 is C, D, E, F, and then 16 is 1, 0. Everybody follow what's going on? How you could just make a whole page of counting in base 16. So now, what's C plus D? What's C? 12. What's D? 13. What's 12 and 13? 25. How do I say 25 in base 16? 116 and what? 16 plus what is 25? 19. Everybody follow that? 25 is 19. If we'd have kept going, maybe we should put it over here. 17, 18, 19, 20, 21, 22, 23, 24, 25. Let's see. 16 is 10. So that's 1, 1 in the base 16. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Getting too excited here. 1, 8, and 1, 9 in the base 16. So we put down the 9 and carry the 1. What's B? B is 11. So we have 11, and 1 is 12, and 5 is 17. How do I say 17 in base 16? 1, 16, and 1, 1. So I put down a 1 and carry a 1, and 2 and 1 is 3. Is that the correct answer? Good. And 25B is not on the test.
Sigh of relief.
Yeah. Because if it took us this long to work through these problems, there's just not enough time to do everything on the test. But if do you see how you're kind of doing the same thing over and over? You just change the base. So now what happens is you have a handle on this whole concept. Now, I'm sorry the tablet wasn't working, but we're done practicing for the test. If you know what to do, you can take off. If you don't know what to do, then move up here to one of these closer tables and I'll answer questions for you. Like, for example, you say, well, some of those you skipped, I don't know how to work them. Well, come on up here and I'll help you with your homework. Otherwise, you can take off. What? The machine should break more often? We get through class earlier this way? No.